On section 9.4, which is the last section before the second test. It's a section on volume and surface area, and I sense that these topics could be topics you've already covered in some previous classes. So the first thing I want to look at is volume, and this is just from the notes that I have online. Volume says it's the amount of three-dimensional space an object occupies, and it says capacity. Basically, volume is in cubic units, and it measures really how many cubes you can fit in a certain object. So if I could actually draw a cube, which I don't think I can, but this is supposed to be a cube. That's a perfect kind of square. If you have a cube that's 1 unit by 1 unit by 1 unit, so if it's 1 unit wide, 1 unit high, and 1 unit deep, that would be a cube that is 1 cubic unit. So this is a 1 cubic unit. And if these ones were inches, then I'd say the volume of this cube would be 1 cubic inch. So volume is one of the two concepts that we're going to study in this section. The other topic we're going to study is surface area. And surface area is the sum of all the surfaces, the areas of each of the surfaces of an object. So this picture down here, this cube, if I could physically find the area of each surface, so there's a side back here, there's a side here. This cube has 1, 2, 3, 4, 5, 6 sides. If I found the area of each one of the sides independently and added it up, that would give me the surface area for that cube. When we get into the section, I'll do a bunch of problems and teach you how to compute surface area in volume. But volume is just how many cubes could fit in the object, and the surface area is the sum of the area of all the faces for an object. There's an example here to compute the volume of this rectangular object here, and I'll dispense with that, look at some formulas, and then do a bunch of problems. So when we're dealing with volume and surface area, it's nice to know the names of objects and the formulas that will help us compute the volume and surface area. So this page in my notes is something you should have to reference as we're going through section 9.4, because it has every formula that I think you might need. Some of the pictures are a little bit distorted. The first object here that we call a rectangular solid, you might call it a box. It's just, basically a rectangular three-dimensional object, and I'm given a volume formula, length times width times height, and then a surface area formula, which is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. So if you just kind of scan this page and just familiarize yourself with the objects a little bit, this would not be a bad use of your time. So as I look at the object, the second object is called a prism. What's pictured here is a triangular prism, because the base of this object is a triangle, and then the sides of this object, if you look at any of the sides, they're rectangles. This thing that looks like a Coke can we call a cylinder. This object that has 4 triangular sides and a rectangular base is a pyramid. And then if you have a cone, I think you might know what that is, and like an ice cream cone, I guess, like a sugar cone. Cone itself is a cone. And then this picture is really distorted. This is supposed to be a perfectly round ball. Looks certainly a lot more like a football than it does a perfectly round ball. So this is like a basketball or baseball we call a sphere. I'm not going to attempt to draw it. I can't definitely draw it any better than that. even though this isn't the best representation. So I'm going to keep these formulas right next to me as I do the problems in the handout, and I'll have the formulas right next to me as I do the problems in the text that I wind up doing. So the first page of this handout that has problems on it, for whatever reason, at least the page that I have staring at me, starts with problem 8, and I'm not sure why that is. If I just happen to clip a little bit of this handout and not take everything with me, I'm not sure what I did or didn't do, but hopefully you can turn to this page of my handout if it doesn't happen to be the third page. For me, it was my third page this morning, afternoon should I say, but maybe it's not yours. So immediately, each one of these problems presents me a picture and asks me to find the volume and the surface area. So as I go through and I look at the picture, I have to identify its shape. In this problem that I call 8, I'll define that as a cylinder. Looks somewhat like the picture in the drawing on the page of formulas. And what I need to have is two different amounts. I need to have an R. This 6 centimeters is the radius of the circular top. So I'm going to write R is 6 centimeters. And I need a height. And the height I'm assuming is this 5 centimeters. In addition to having those amounts, I need formulas. The formula for volume is pi r squared times the height. And the formula for surface area is 2 pi r plus 2 pi r h plus 2 pi r squared. So in order to answer the question as to what the surface area is and or what the volume is, I have to have the formula. And I don't want you to memorize any of these volume formulas. I'll either give them to you or let you use a note card on the test. You just have to be able to use the formulas. For my purposes, I'm going to use pi for every single, 3.14 for pi. So when I do the volume of this, I'm going to write a V for volume. I'm going to write a 3.14 for pi. If you use your pi button on your calculator, that's probably better than using 3.14, and you'll get an answer that's slightly different than mine. And if you do that on the test, I'll be able to figure out if your answer seems right or not. But anyways, I'm using 3.14 for pi. And then for r squared means r times r. Squaring something is to multiply it by itself. So instead of writing r squared, I'm going to write 6 centimeters times 6 centimeters. R squared means to multiply the radius by itself. I'm putting units in so I get the right units in my answer. And the last part of the formula is the height times 5 centimeters. So my units in my answer for the volume, I see centimeters times centimeters times centimeters. So I'm going to get cubic centimeters. I'm just going to write a centimeter symbol with an exponent of 3. Could write the word cubic centimeters. The number that's going to attach to the cubic centimeter answer is going to be 3.14 times 6 times 6 times 5. And I'm going to round it 2 decimals. And since I only have 1 decimal in my answer, I'm just going to give you that decimal. So I'm going to say the volume of that cylinder is 565.2 cubic centimeters. So there's 565.2 cubes that are 1 by 1 centimeter by 1 centimeter by 1 centimeter that could fill that up if this was a actual scale drawing. Next thing I'm going to do is the surface area. I see the formula for the surface area, so I'm going to just do it. I'm going to write 2 times pi. I'm going to write 3.14. I see another r, and the r is 6 centimeters. I see an h, and the h is 5 centimeters. Then I'm going to put a plus sign, and I see the number 2 again. Then I see a pi again, which is 3.14. And then for r squared, I'm going to put 6 centimeters times 6 centimeters. Let me do this number, and then that. I guess I could do it all in one. So for the first number, it's going to be 2 times 3.14 times 6 times 5. And that's 188.4. And Because the units are centimeters times centimeters, it's going to be square centimeters. So the first computation gives me 188.4 square centimeters, which I wrote with a centimeter abbreviation with an exponent of 2. The next computation is 2 times 3.14 times 3.14 times 6 times 6, and that's 709. I messed up. 2 times 3.14 times 6 times 6 is 226.08 centimeters squared, because it's centimeters times centimeters. Now I'm going to add these and get the surface area. My first answer was a volume because I was asked to compute a volume. And my second answer, I'm going to write SA for surface area. I'm just going to add these two amounts. I'm going to add the 188.4 square centimeters plus 226.08 square centimeters. It's going to give me 414.48 square centimeters, or centimeters squared, for the surface area. So hopefully I haven't done anything horribly wrong with my calculator. I'm just going to redo this computation real quickly to make sure I haven't messed up. No, I didn't. All right, so I'm going to go do problem 9, which I have 2 problem 9s, and then 9 again, and then 10. So I'm not really sure what's going on with the numbering at all here. So I'm going to do the 4 problems on the page. The next problem I'm going to do is this rectangular solid, or a box. I need formulas and I need dimensions. And the formula for the volume is length times width times height. The formula for the surface area is 2 length times the width plus 2 length times the height plus 2 width times the height. It turns out that you can make any of the dimensions a length, any of the width, any of the height, and you wouldn't go wrong. Generally, the longest dimension we make the length. So I'm going to call this 10 feet the length. And then as I look at the picture that's given, this 3 feet looks more like the height because it's going up, and that by default makes this 2 feet the width. So when I go to find my values for volume and surface area, I'm using 3 for the height, 10 for the length, and 2 for the width. If you switch like the W and the H, it wouldn't. Your answers will be the same number. So for volume, I'm going to write V equals, and then length is 10 feet. I'll put my units in, so make sure to get the right units. And then times width is 2 feet, times height is 3 feet. I'm going to multiply 10 times 2 times 3. That's something I don't even need my calculator for. 10 times 2 is 20, times 3 is 60. And then my units are feet times feet times feet, so that's going to be feet cubed, or cubic feet. So the volume of that rectangular solid is going to be 60 cubic feet. Now I'm going to do the surface area, which is adding up the areas of all 6 faces. And our author, or this gives me an S, I'm writing SA. So I'm going to say the surface area is 2 times the length, which is 10 foot, times the width, which is 2 foot, plus 2 times the length, which is 10 foot, times the height, which is 3 feet, plus 2 times the width, which is 2 feet, times the length, which is 10 feet, times the height, which is 3 feet, should I say. So each computation is a multiplication of 3 numbers. So for the first one, 2 times 10 times 2 is going to be 40. And then feet times feet is going to be square feet. So the 2LW gives me 40 square feet. Now I'm going to do the 2LH. That's 2 times 10 times 3, which is 60. And then feet times feet is feet squared. And then lastly, 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. And that's going to be 12 square feet. If I add these up now, 40 square feet plus 60 square feet is 100 square feet, plus 12 square feet is 112 square feet. So I did this without a calculator. I'm going to say the surface area is 112 square feet. When I get to this next number 9, this is actually a cone as opposed to a pyramid. Both a cone and a pyramid have a point at the top, but a pyramid has a, well, it could have a rectangular base. It doesn't have a round base, whereas a cone has a round base. So this is a cone, and the values that I need in a cone are, well, it would be nice if I gave you this S, but I don't really need this S. I do need an H and an R, and if I have an H and an R, I can use the volume formula that has an H and an R, and I can use the surface area formula with an H and an R. And those are the values I'm going to need. In this particular problem, I believe the height is going to be the 25 meters, and the radius is going to be this 8 meters. And for the volume, I can type the formulas in. So I'm going to use 1/3 times pi. So for this, I'm going to go volume equals 1/3. I'm going to plug in 3.14 for pi. For r squared, I'm going to go 8 meters times 8 meters, because squaring means to multiply by itself. And then times the height, I'm going to go times 25 meters. When I do this computation, I'm going to be careful with this 1/3 and put it in a parentheses. If I don't put the 1/3 in a parentheses, so I did 1 divided by 3, put it in a parentheses. If I don't, it might think everything that I typed after the 1/3 is in the denominator of the fraction, which it isn't. So now I'm going to go times 3.14 times 8 times 8 times 25, and I get 1,674, and I'm going to round to 2 decimal places. It doesn't say how far to round on this sheet, so I'm just going to go to 2 decimal places. The number in the second decimal place is a 6. The number in the third decimal place is another 6. It's going to make me round that 6 up in the second decimal place to a 7. So I'm going to say the volume for a number is 1674.67, and then units are meters times meters times meters. So it's going to be cubic meters. Surface area of this cone, this formula is a mess. It has a square root in it, but I can deal with it. So surface area, which I'm going to write as SA, equals pi, which is 3.14, times r squared, which is going to be 8 meters times 8 meters, plus pi, which is 3.14, times r, which is 8 meters, and then this is a wreck here, times the square root, and this I'm spinning into my other problem, of r squared, which is 8 meters times 8 meters, plus h squared, which is 25 meters times 25 meters. Let me work on this square root. So, better yet, let me just work from left to right, and I'll get to that square root in a second. So the surface area is going to be 3.14 times 8, and then in the first units before the plus sign, it's going to be square meters, because I'm multiplying meters times meters, and the number that's going to go there is 3.14 times 8 times 8. That's 200.96 square meters. And then, off to the next part, I'm going to go 3.14 times 8 meters. I'm going to do the square root of this 8 meters times 8 meters plus 25 meters plus 25 meters. Let me get that square root taken care of first. Under the square root, I have 8 times 8 plus 25 times 25. Under the square root, I get 8 meters times 8 meters, which is 64 meters squared, plus 25 meters times 25 meters, which is 625 meters squared, which is going to give me the square root of 689 meters squared. I'm going to do the square root. So second square root, you might have to learn your own calculator and how to do square roots. I get 26, I'm going to round to 2 decimals, I'm going to write 26.25. So this is going to be plus 3.14 times 8 meters, and then in place of the square root, of 689 meters squared, I'm going to write 26.25. And it's not going to be meters squared anymore because the square root of meters squared gives me just a meter. So this first half of the formula, the pi r squared, was easy to do. The second half of the formula is getting rather tedious. I'm still not done with it. So now I'm going to get the second half of what's to the right of the plus sign down to a single number. The units are going to be meters times meters or meters squared. So for the second half of the formula, I go 3.14 times 8 times 26.25, which gives me 659.4 meters squared. So the volume of this is going to be this 200, or the surface area of this is going to be this 200.96 square meters plus what this came out to be, 659.4 square meters. When I add those two amounts together, the 200.96 square meters plus the 659.4 square meters, I get 860.36 square meters, and that's going to be the surface area of the cone. So for the last part of my cone, the surface area is going to be 860.36 meters squared. This is really unpleasant. The sphere, this is supposed to be a three-dimensional sphere, somewhat like the picture on the bottom of this page. Neither one's a very good picture, but the one on this page is a little bit better than the one on that page. If I look at the volume formula and the surface area formula, I see 4/3 pi r cubed, 4 pi r squared. The only number I need is r, and I wasn't really able to get that in there, so I said the radius is 4 miles. Clearly that's not a 4 miles, but it's what we're calling the radius. So the volume of this sphere, I have the formula here. The volume is going to be 4/3 times pi, which I'm going to write 3.14, times radius cubed. And the radius is 4 miles, so I'm going to go 4 miles times 4 miles times 4 miles, because cubing something means to multiply it by itself 3 times. So the volume of this, is the units are going to be miles times miles times miles, which is cubic miles, or miles cubed. And then the number, I'm going to put 4 divided by 3 in a parentheses for the 4/3, and then times 3.14 times 4 times 4 times 4, and I get 267.94. The number after the 4 is a 6, if you could see that. I don't know if you can or can't, but I'm going to round the 267.946 to 267.95, just because I'm consistently rounding to 2 decimals. So the volume of that cube is 267.95 cubic miles. The surface area, I think I can sneak right in. The formula is just 4 pi r squared. So the surface area is going to be 4. Then I'm going to put 3.14 in for pi, and then for r squared, I'm going to say 4 miles times 4 miles. And I can do that quickly. I'm going to go 4 times 3.14 times 4 times 4. I get 200.96 is the number, and it's miles times miles or miles squared. So the surface area is going to be 200.96 square miles. This is supposed to inspire you to be able to do some of the problems on page 515 in the text. As I look at the problems in page 515 in the text, one of the big deals is just going to be to know what to call the object and what formula is going to be necessary for the area, for the surface area and the volume. In problems 7 through 20, I'm only asked to find the volume. The problem 7 and problem 8, these are going to be rectangular solids. And the volume formula for both problem 7 and problem 8 is going to be the length times the width times the height. Problems 9 and 10 are cylinders. And when you go to do problem 9 and 10, the volume formula that you're going to need is pi r squared H. Problem 11 and 12 are cones. The volume formula that you're going to need when you attack 11 and 12 is 1/3 pi r squared h. And then we start to get a little bit into these sneaky problems. 13 and 14 are prisms. And 13 and 14, the volume is the area of the base times the height. So when you go to do 13, I'm going to consider this trapezoid the base, and the height I'm going to consider 24. So when you go to do the volume of this, the volume is the area of the base times the height, which means to find the area of the base, you have to remember the formula for the area of a trapezoid. And if you don't have that memorized, then you can flip back a few pages and you can find the area of a formula for a trapezoid because it's given in the text. Again, it's not something I'm going to make you memorize. The area of a trapezoid is, so this base part, that's the area of the trapezoid. The area formula for a trapezoid is 1/2 times the height times the sum of the bases. So just not to do this problem all the way out, in this problem, this B is finding the area of this trapezoid. That's a top or a bottom. And if I look at this 10 is going to be the height, and the bases are going to be the 12 and the 8. So when you go to do the volume in number 13, this B part right here, really this is going to be volume equal 1/2 times the height times base 1 plus base 2 times the height again. There's two different heights here. This height, the 24, is the height of the prism, and this height is the height, the 10, of the trapezoidal base. So hopefully that inspires you enough to be able to do 13 by yourself. If you can't do 13 by yourself, it's not a big deal at all. Ask me in class and I'll do it for you. 14 is not a homework problem. 15 and 16 are spheres, and the volume formula for the sphere that I need is 4/3 pi r cubed. You'll notice that in 15, this is the 9 is a diameter because it's the distance all the way across. If you divide that in 2 and get 4.5 centimeters, that's going to be the radius that's needed. Problems 17 and 19 are pyramids. Pyramids are also they're similar to prisms. The volume formula is 1/3 the area of the base times the height. I'll just sketch out 17 for you. If I look at 17, the volume is going to be 1/3 the area of the base times the height, and the height that the author wants is this right here, this 13 centimeters. So that height is going to be 13 centimeters. And then the base is supposed to be a square. Not that I just drew a square. That's 11 by 11 centimeters. For the B in this formula, that's going to be the area of a square, which is just the side times the side. So that's going to be 11 times 11. Again, I'm not going to do the problem all the way out. Hopefully I've inspired you enough to be able to do the volume for that figure. If not, any of the problems that I assigned for homework were basically the odd problems on this page. If you can't quite get them, then ask me and I'll do them in class. So hopefully the 4 problems that I did with volume plus this little sketch here is going to give you the skills that you need to get through. All right. So problems 21 through 28. It says find the shaded area. I probably should really say find the shaded volume. Area is probably not the best word for that. And let me just do problems 22 and 24. I'm 99.99% sure that these problems don't make their way onto the test because I have no idea how to draw these using Word. I just have to cut and paste things I found from the internet. So let me try to explain problem 22. So in problem 22, I have a cylinder and a cone inside a cylinder, and the shaded volume, or the shaded region might be better than volume, is going to be the volume of the whole cylinder minus the volume of the cone. And I'll try to, I think with probably not a lot of success, draw each one of these pieces. So the cylinder that we're looking at in problem 22 is a cylinder that's 9 centimeters high, and it has a diameter of 4 centimeters. Don't have the volume formula for a cylinder memorized, but the volume is pi r squared h. The r is going to be half of that d, or it's going to be 2 centimeters. So the volume for this cylinder is going to be, again, the formula for the volume for a cylinder is pi r squared h. Pi, I'm going to write 3.14. For r squared, I'm going to write 2 centimeters times 2 centimeters. And for the height, it's going to be the 9 centimeters. So the volume of the cylinder, without, that's the whole region, I'm going to subtract out the volume of the cone, is 3.14 times 2 times 2 times 9, and I'm going to get 113.04 cubic centimeters. So for the volume of the cylinder part of this, that's 113.04 cubic centimeters. And then inside this figure, there's a cone that I need to subtract the volume of it out. And again, I don't have that volume formula memorized, so I sneak to my sheet. The volume for a cone is 1/3 times pi r squared h. And the nice thing about this cone, again, it has the same dimensions. Its radius and its height are going to be the same as the radius and the height for the cylinder. So the radius is going to be the halfway across the circle, which is 2 centimeters. The height is going to be the 9 centimeters. So the volume for the cone is going to be 1/3 times 3.14. For r squared, I'm going to write 2 centimeters times 2 centimeters, and then times 9 centimeters for the height. So parentheses, 1 divided by 3, parentheses, times 2 times 2 times 9. I get, whoa, I forgot the pi, that's why. Oh. Parentheses, 1 divided by 3 times pi, 3.14, times 2 times 2 times 9. It's going to give me 37.68 cubic centimeters. So the volume of the whole cylinder is 113.04 cubic centimeters. The volume of the cone, so I take the volume of the cylinder minus the volume of the cone. That's going to give me the volume, or the shaded region's volume, or the area of the shaded region, which really is not the proper word. I'm going to subtract these. I'm going to go 113.04 minus 37.68. And I get 75.36 cubic centimeters. In fact, that's all I'm going to do in this group of problems. Like I said, I'm virtually certain that this bank of problems between 21 and 28 aren't on the test. When I print out the review, if I happen to see one of those problems, I'll come back and do some more of these when I'm doing the review. But I'm pretty sure we don't have to worry about those. So far in this section, I talked about volume and surface area. Apparently, none of the problems had surface area, so I gave you more than you needed to have there. Did some formulas, just doing volumes and surface areas. These aren't that important. This last bank of problems right here, I'm going to focus on, and I'm pretty sure these problems between 29 and 32 and 33 and 36 and some of the higher problems, I'm pretty sure I actually typed up what I needed to here. And I'm going to get back to the handout, which is really getting back to the text. So I very specifically said, well, there are a few problems that I just can't draw, 22, 24, and 26. I did 22, quite honestly. I'm just saying, let's just skip 24 and 26. And if you want to ask me in class how important these are, I'll tell you. I'm just pretty sure they're not that important. What is going to be important, because they're easy for me to write on the test, and I kind of tied some earlier stuff with this stuff, are the problems between 29 and 32, and some of the word problems that are a little bit higher. I'm going to do all these, so hopefully you have this printed out, or you have the text in front of you. So this is problem 30 from section 9.4. If this is too small for you to see, then you should have your book open. You can see it. So the problem says convert 3.8 cubic yards to cubic feet. And the beautiful thing is the author gives me a little bit of information. It says use the fact that 1 cubic yard is 27 cubic feet. So what I'm going to do is I'm going to start with the 3.8 cubic yards that I have. And I'm going to multiply by a fraction. In the numerator, it's the units that I want. I want to have cubic feet, so I'm going to put 27 cubic feet in the numerator. And the denominator is going to be the units I'm trying to get rid of, which is the yards cubed. So if I multiply the 3.8 yards cubed, cubic yards, by 27 cubic feet over 1 cubic yard, good things will happen in terms of the units. In the units, the yards cubes are going to cancel. The units that haven't canceled are going to be my cubic feet. And the number that I get by completing this is going to be the numerical part of my answer. Because the 27 is in the numerator, I'm going to multiply it by the 3.8. So I'm just going to go 3.8 times 27. And I get 102.6 cubic feet. So that would be the answer to problem 30. If you look at problem 29, it should be very similar. Now I'll do 32, and 32 should be very similar to 31. So 32 wants me to take 2,457 cubic feet, so I'm going to write that down. I want to start with 2,457 cubic feet. I want to convert that to cubic yards. So in the denominator, I'm going to put what I want to get rid of. In the numerator, I'm going to put the unit of what I want. I want cubic yards. I'm going to put that in the numerator. 1 yard cube is a cubic yard. In the denominator, I'm going to put what's equal to it, which is 27 cubic feet. I set my units up to cancel. The cubic feet are going to cancel. The units are going to be left in my answer, the cubic yards. I could write cubic yards if I care to, but I won't. I'll write YD with an exponent of 3 to represent cubic yards. And then the number I'm going to get here, I'm going to have to divide because the 27's in the denominator. So I'm going to go 2457 divided by 27, and that's going to give me 91 cubic yards. So the answer to problem 32 is that 2,457 cubic feet is equivalent to 91 cubic yards. The next 3 problems are word problems from the section. So I'm going to do problem 39. And this is it's a 2-step problem. It talks about a bread pan. A bread pan, I'm assuming, is a rectangular solid, even though the top, it doesn't have a top to it. But a bread pan is in the shape of a rectangular solid. It says, how many quarts does a bread pan hold if 1 cubic inch is that many quarts? What I need to do is a 2-step problem. First of all, I need to find the volume of the bread pan in cubic inches, and then I'm going to convert from cubic inches to quarts. So in 2 steps. The first step is to find the volume of the bread pan. The volume of the bread pan, because I'm assuming it's a rectangular solid, is length times width times height, which is going to be 12 inches times 4 inches times 3 inches. When I multiply those together, I get 144 for the number. I can multiply that in my head. You can use the calculator. And then inches times inches times inches is cubic inches. Now I'm going to convert that to quarts. So I'm going to take the volume, that's 144 cubic inches that I just computed by using the volume formula. I'm going to multiply it by the unit. In the denominator, it's the unit that I want to get rid of. I want to get rid of cubic inches. In the numerator, it's the unit that I want, which is quarts. That's 0.01736 quarts. Again, I wouldn't ever want you to memorize that. I'll give it to you on the test if you need that. So I'm going to cancel my units. Because the number is in the numerator, I'm going to multiply. My units and my answer is going to be units that's left, which is quarts. That's what I'm searching for. And when I multiply the 144 times this 0.01736, I get the number that I want. I get 2.49984 quarts, and I'm going to round this to 2 decimals. That's how I've been rounding. This 9 in the 3rd decimal place, what's going to do, it's going to round that 9 up to a 10, and I'm going to carry the 1 over and round that 4 up to a 5. So I'm going to say this is 2.50 quarts, which makes more sense, 2.5 quarts. If you would have written 2.49984 quarts and given me a non-rounded answer, I'd be content with that. But since I've been rounding the 2 decimals, I feel the need to be consistent. So last 2 problems worked in parallel. 42A and B is like 39 separated into 2 problems. In 39, I took the bread pan, found its volume, then converted from volume to quarts, all in one problem. 42A asks me to find the volume, and then 42B wants me to convert from volume to kiloliters. So let me do part A. So I have a swimming pool that's 15 meters long, 9 meters wide, and has an average depth of 2 meters. Just like a bread pan, that's also a rectangular solid. It says, what's the volume of the swimming pool? Volume is length times width times height. Length is 15 meters. Width is 9 meters. Height is 2 meters. So the volume of this pool is 15 times 9 times 2. Again, I can do that in my head. It's 270 cubic meters. That's the answer to part A. Part B says if 1 cubic meter is 1 kiloliter, KL means kiloliter, how many kiloliters water will it hold? Well, I'm going to do the conversion. I'll take 270 meters cubed times the fraction that I want. In the numerator, I'm going to put the unit that I want. In the denominator, I'm going to put the unit that I want to get rid of. I want to get rid of meters cubed. I want to have kiloliters. So in the numerator, I'm going to put a kiloliters. In the denominator, I'm going to put meters cubed. I'm going to cancel the cubic meters. The units that I have left are kiloliters. And there isn't anything to do. I'm multiplying by 1 or dividing by 1. That 270 is just going to stay 270. So the answer to 42B is going to be 270 kiloliters. All right, hopefully that inspires you enough to be able to do all the homework problems. Again, as you're doing the homework, maybe really lightly look at 21 through 28. Maybe try 21, maybe try 23, but don't dwell on these. I don't think they're on the test. Do make sure you can compute basic volumes. Apparently, you just don't need to do surface area, although I gave you surface area for free in my lecture. And so make sure you can do volumes of basic shapes. And these problems between 29 and 32 and the problems between 37 and 41 that I assigned, focus on those because these are easy for me to write up. They don't involve me trying to recreate a 3-dimensional shape. So these are likely going to make their way into the test from this section. So that should be the end of this section and the last bit of information that we needed to cover before the second test. So by now, you should hopefully be ready to print out the review for the test over this chapter and the stuff that we've been working on. And then take that and treat it like a test. If you can do all the problems on the review well, then you'll be completely ready for the test. I'll do the review in class. Also, there is a video of me solving the review. It would be nice, though, if you try to complete the review without watching the video before having me do it in class, because that will just gauge how well you understand the material. And absolutely, at a bare minimum, I will give you every formula that you need for this chapter. I don't want you to have memorize any formulas. More than likely, I'll let you use a note card on the test so that you can write down the formulas and you can write down anything that might help you do the problems on this test. Okay, so hopefully that was understandable.